All right, so 12.1 and 12.2. We're going to start with a word problem. This word problem carries through to both sections, which is why we're doing them together. We'll spend 75% of the time doing section 1, and then the last 5 or 10 minutes section 12.2, because it's really pretty short. Does anybody want to read the paragraph about Miss Picasso? Anybody? A reader? Thanks, Jonathan.
Miss Picasso, sponsor for her school's art club, sells calendars featuring student artwork to raise money for art supplies. A local print shop sponsors the calendar sale and donates the printing and supplies. From past experience, Miss Picasso knows that she can sell 150 calendars for $3 each. She considers raising the price to try and increase the profit that the club can earn from the sale. However, she realizes that by raising the price, the club will sell fewer than 150 calendars.
Thank you. Does this word problem make sense? It's not super tricky. This is the word problem we're going to talk about all hour. So we have calendars. Currently, they're $3, and we'll sell 150 if we keep that the same. She could raise the price, make more money, but then she's going to sell less of them. So does she really make more? It's kind of hard to tell. Just kind of what we're going to talk about this lesson. So number 1, if Miss Picasso raises the price of the calendars by X dollars, write an expression for the price of one calendar. Circle price of one calendar. That's what we need. How much is the calendar currently? $3. Are we going to add or subtract to it? Add. So $3 plus how much are we adding? X. X is the increased price. That's it. That is how much a calendar will cost. 3 plus whatever I decide to add to it. Number 2. In previous years, Miss Picasso found that for each 40-cent increase in price, the number of calendars sold decreased by 10. Complete the table below to show the relationship between the price increase and the number of calendars sold. So we have the starting point, $0 increase. We're going to sell 150 of them. Did they do a nice increase of 40 cents like they described? Well, that's convenient for us. So if I go up by 40 cents, the calendars sold are going down by 10. So I'm going to sell 140. Did they nicely go up by 40 cents again? Yep. So our calendar decreases by, we're only going to sell 130. Did they again go up by 40 cents? You got to be careful because your book doesn't always do that. Sometimes they jump. But yeah, they did go up by 40 more cents. So I'm going to sell 10 less calendars. Number 3, use the data in the table to write an expression for the number of calendars sold in terms of X, the price increase. Let's circle number of calendars sold. You might remember a couple weeks ago, I would say make a table, pass it to a friend, and see if they can write an equation for it. Here you go. Here's your table. No passing to a friend. Here's your table. Write a linear equation for that. When you get your slope, feel free to simplify it so it's kind of a nice number. It should be a fraction, but when you type the fraction in, you should get a good number. Keep going if you are on a roll. If not, and you need help, look up here. I'm gonna find the slope first. We kind of know the slope because we did a constant rate of change every time, but if I'm doing slope, I'm gonna pick 2 points. I'm gonna go with this point and this point. So I'm gonna do y minus y over x minus x. So y minus y is going to be 10. X minus x is negative 0.4. Here's why I said you might get a fraction, which is fine. Type this in, or maybe you already did. What do you get when you take 10 divided by negative 0.4? Yeah.
Negative 25.
Yeah, that's a much better number and easier to understand than 10 over negative 0.4. So that's your slope. Is it going to be difficult to find our intercept?
No, because they already have.
It's right here. When x is 0, that's your y-intercept, so 150. If we didn't have that, we could plug in a point, an x and a y, and our only unknown would be this, so we could find it, but we've already got it. So we have a slope of negative 25 and a y-intercept of 150. So they only want an expression, so you don't have to write the y equals. What is this an expression for? This is the number of calendars we're going to sell. We sell 150, but it's going to be changing depending on what x is. Number 4, write a function that models the amount of money raised selling the calendars when the price is increased by x dollars. Let's circle amount of money raised. I'm going to put it in words before I put it in numbers. Let's take some objects you've done. Have you guys been a part of a fundraiser where you sell shirts before? Let's say, for example, you sell 12 shirts and each shirt was $9. How would you figure out how much money you raised? You sold 12 and each one was $9.
12 times 9.
That's it, right? How many I sell times how much they cost is how much was raised. So let's write that out in words. If I want to know how much I raised, I want to know number of items sold times the cost of each item. Now we sort of understand what they're asking us for. I'm walking you through this, but if this was a quiz, you would just have to read this a couple of times and say, okay, what am I supposed to write? I'm supposed to write about the money raised. How do I figure out how much money is raised? And just kind of think it through in terms of a problem you're familiar with. How do I figure out how much money is raised? And this is how you do it. So they want us to call this function a of x. And we need to know the number of items we sold. That's why I had you circle this right here. Number of calendars sold is this expression, negative 25x plus 150. Multiply that times the cost of each item, which I had you circle up here. The price of one, 3 plus x. Okay, we're going to do a lot of things with this. We're going to get it in standard form. We're going to answer a bunch of questions. We're going to graph, domain range, tons of things. We're going to kind of be skipping around in your book. You might want to just get a separate piece of paper out and not really do your book because we're just going to be writing extra stuff and also skipping some stuff. So it's up to you. I'm just going to kind of keep going in a line. So the first thing I want you to do is take this equation and get it in standard form. Can somebody tell me what this function is for? What is x? And what does the function give us as an output? Should see lots of hands. What is x? And what do I get when I put x in and get an output? Jonathan?
X is your price and.
Price.
What do you?
Anybody correct that just a little bit? X, well, what are we going to say after that? X is the price.
It's the increase.
There you go. Is that what you're going to say? Yeah, so we have to be careful not to say X is the price of the calendar. It's the price increase. There you go. That's what I was looking for. X is the price increase for per calendar, and your output is?
The number of calendars.
I think the number of calendars sold was right here. What does this function tell us? The amount of money raised. If the calendar increases by $1, I put in 1 and I find out how much was raised. If the calendars are sold for $2 extra, I put in 2 here. My output is how much money raised. So let's, somewhere by the function, let's kind of write that down. X is the cost increase. I do this pretty much every time I write a new equation and it's a word problem. I always make myself a point and I say, what's X and what's Y? X is the cost increase and Y is, how did they phrase it? Money raised or amount raised. So if you're following along in our book, we've done, thank you, we've done 1 through 5. Number 6 is going to have us graph it, so we're going to hold off on that for just a second. What I would like us to do, I'd like us to solve this. So solving means set it equal to 0. We have a couple options for solving, and this is not in your book, so you can do it in the margins or your separate piece of paper. We've got about 4 ways we can solve a quadratic. How do we feel about factoring? Should we do that for this problem? Nah, maybe it'll come out nicely, but maybe not. What about square roots? Not possible, right? Can't do square roots with a B term. Do we want to complete the square? That's going to kind of be a mess. So I have to divide by -25. I've got to move the C term. I've got to fill in the blank. A lot. So what's our best choice for usually word problems? Quadratic formula. Let's do the quadratic formula to solve this. Works out to be a perfect square. Your discriminant is a perfect square. Just keep going. This is a word problem. If I have a decimal, that's okay. Just keep going. Figure out what you get for X when you solve it. One word of caution, if you're typing this in your calculator, you need to put the top in parentheses or hit enter before you divide by -50, or else it will only divide the 225. Before we talk too much about what this means, we're going to get a graph and see where these numbers, -3 and 6, appear. Raise your hand if you'd like some more time with this solving. All right, fire up your graphing calculator. You're going to type in this function. Of course, you can't hit a of x, but just go to y equals and type in that function. Well, if you're borrowing one of mine, maybe somebody last hour already did that. Hopefully not. When you type in -25, make sure you use the negative by enter, not the minus. The x is up by the green alpha. If you're ready, you can go ahead and graph it then. You'll probably see your graph isn't big enough. But that makes sense because our problem is in like the 450s. And my graph is only going 10 to 10. So what needs to be adjusted? Do I need my x direction to be any bigger? No, I don't need to go any bigger that way. I don't really need negative profit or negative money raised. The only direction I need to go is up in the y direction. So go to window. The only number you should adjust is the up direction, which is your y maximum. Well, let's try. We know our graph says 450 in there, so let's try 500. Oops. I put it at the scale. Y. Don't change your scale. Y maximum 500. That's better. I'm missing a little part, so I'm just going to make it a little higher. I'll go 600. Raise your hand if you want me to come around and figure out what your calculator did wrong. What you did wrong. Oh, your plot. So go up to plot, hit enter. Now hit graph. Now window. Looks like your x is going to 600 instead of your y. That should just be -10 to 10. Yep, go to window. Your x's should be -10 to 10. Anybody else? Yeah, change that y scale back to 1. That should be 1. And go up to the next scale, make that 1. Oh, no. That should have been 10. Get clear. Okay, -10. And up and 1. Start graphing now. What in the world? I don't think you have a quadrant. Go to y equals. Oh, you forgot squared. So just hit over to the. Now hit second. Insert. There you go. Squared. No, that's what I typed. I'll do it. So I'm going to do a little faster. Okay, now try to graph. There we go. Anybody else? Okay, these answers that were on our last problem. -3 and 6. Do you see what's happening there? Do you see an x of 3 and an x of 6? What's happening? Right here. When x is 3, I'm right there. And when I'm at 6, I'm right there. Which, if you think about it, didn't we plug in a 0 for y? And aren't these the points when our height is 0? That will happen every time. When you're solving, you're getting the x-intercepts, which is a height of 0 in the y direction. What would this mean in terms of calendars or our word problem? Can somebody tell me that? Look at this. It's negative 3 and 6 mean, or let's just go with 6. Yeah.
Price of one calendar.
Isn't this price increase? So this is saying if I increase the price by $6, what was my outcome for that? I make no money, right? That would be way too high. I would raise it so much that I wouldn't actually make money. So this is what we call a break-even point. You don't make money, you don't lose money. If you sell it for $6 more, you're going to raise $0. Also, can we have a negative? Most word problems you can't. If X is cost increase, what would a negative X mean? If X is cost increase, what would negative mean? Yeah, it'd be cost decrease. So if X is 1, I increase the price by $1. If X is 2, I increase it by $2. If X is negative 3, then I decreased it by $3. It was only 3 to start with, so I'm giving it away for free, and I'm not making any money. So we call those break-even points. Any cost in between negative 3 and 6 increase, you will make money. Told you we're going to jump around a little bit. You'll need this information, but if you go to page 197, number 2, page 197, number 2, it says this.
Help for this, like, can't if you make it high, won't you automatically be making money or not?
Well, then nobody would buy it. Your calendars would be like $80, and people would be like, no, thanks. Yeah, that's what happens. Because remember, every 40-cent increase, we sell 10 less, so eventually you're going to sell 9. Good question. 197, number 2, we've already kind of done. What are the x-intercepts of the graph? What are the significance of the x-intercepts in terms of this counter? That's what we just did, but you might want to make a note there or on your scratch paper. X-intercepts, that's when your y is 0. Anytime it asks for an x-intercept, your y is 0, which is what we did. We put in a 0 for y. We had to do a bit of solving. Our method of solving was quadratic formula. We've already interpreted the meaning. You can make a note about that if you think you'll forget. The meaning here is if we sell it for $6, we break even, we don't make any money. If we decrease the cost by $3, we make no money. If I'm Miss Picasso and I'm trying to figure out how much to sell these calendars for, what point do I care about on this graph?
The vertex.
Don't I want the highest one? I want the highest output, the highest Y. So let's calculate the vertex. Now, is this function in vertex form? If it was, you could just look at it. If it said this, you would say, oh yeah, the vertex is this. It's not in vertex form. So you can't just look at it and tell the vertex. I am going to show you how to do it graphically and how to do it from looking at it the way it is without being in vertex form. So on your calculator, we're about to calculate the vertex. I believe we've done this before this year. Go to your graph. You want to calculate. That's up by the graph where it says above trace in blue. So second, calculate. We want to calculate the maximum. At the top by trace. You might remember this, left bound. That means your cursor just needs to be to the left of the highest vertex point, the maximum. Once you get there, hit enter. Right bound. Cursor over to the right side of the vertex, vertex. Hit enter. Do we want to guess? We don't want to guess. Just hit enter. I don't know what that guess is for. I've never cared enough to look it up. It's usually going to give you an exact or a very close answer. I don't know why it's off by a little bit. Our decimals were like 9.4 at the end last hour, but you'll get an idea. So this is 1.5 essentially. Let's put this in our notes somewhere. 1.5. And the Y value, 506.25. Yeah.
It's telling me that the maximum is on x equals 0, which
What do you mean it's telling you? It's giving you words or what? Did you hit second calculate?
yeah, that's what I had.
Okay. Wait, don't hit enter again. You did left and right on the same side. Hit enter. Now arrow over to the right side. Keep going. Keep going. There you go. Now hit enter. Now hit enter. You hit enter on the same place too many times.
Okay.
You got it now? It's at the bottom?
Yeah.
Okay. This is your vertex. This is the point we care about. Can somebody please interpret what this point means? Caitlin, what do you think? 1.5 means what?
The cost, the price increase.
Very good. That's why we wrote this up here. So Caitlin says, if we increase the cost by $1.50, then what happens?
We raised $506.27.
Exactly. I'm going to have you write that down, but I want you to add something to it. Look up here. Couldn't we find a bunch of points and tell the cost increase and the amount raised? We could do that, right? What's significant about this one? It is the highest outcome. So don't just say X is this, Y is this. Say X at an X of 1.5, which would be an increase of $1.50. We get the highest money raised at 506.25. Write that down. Let me see where it's at in your book. I'm not sure. It asks you about it somewhere in your book. As long as you have it written down, it's okay. The cost increase of $1.50 gets us the highest amount of money raised, 506.25. Okay. Now I'm going to show you how to get this same vertex without a, well, you might use a calculator, but without using the graphing part of your calculator. I told you it's not in vertex form, so you can't just look at it and write the vertex. But there's something very important on page 195. Page 195, above number 10. It says, the point that represents the maximum value, A of x is the vertex of the parabola, the x coordinate of the vertex of the standard form equation can be used using the formula x equals negative b over 2a. So watch what happens here. If I write that formula, x equals negative b over 2a, and I look at my equation, the opposite of b is negative 75. 2 times a is negative 50. Negative over negative is positive. And 75 divided by 50 is, type it in, 75 divided by 50. Charlie, what do you get?
1.1.
Yep. You can actually find the vertex in standard form if you do this. Make sure you circle this in your book or write it on your scratch paper. Very important. That will give you the X part of your vertex. There is no formula for Y. How do I find Y if I know X? Leroy? Just plug it in. Grab your calculator, plug 1.5 in for X. Let's do that. Did we get 506.25? Should. I would like you to be able to get the vertex both ways. Actually, 3 ways. I would like you to be able to find the vertex from vertex form. This one just isn't in vertex form. I would like you to be able to find the vertex using your graphing calculator. Second, calculate left bound, right bound. And I would like you to be able to find the vertex using this formula for standard form equations. Pretty quick and easy. Opposite of B over 2A. You can put a negative on top or out in front, doesn't matter. But that's how you find it. All right, let's see. We are going to go to page 197, number 1. Page 197, number 1. We've already done number 2. Number 2 was, what are the x-intercepts? And for that, y is 0. But for number 1, it's going to ask us for the y-intercept. Well, if our y-intercept, we know x is going to be 0. I would write that down by number 1 or on your scratch paper. If we are asked to find the y-intercept, x is 0. You guys have heard that before in your math careers, right? You know that. Okay. Okay, let's look up here. How hard is it going to be to plug in a 0 for x? Do we need a calculator for that? Plug in a 0 here, plug in a 0 here. What am I going to get? 450. Very quick to find y-intercept. X-intercept, not so easy. We had to do the whole quadratic formula or factor, complete the square. One of your 4 methods to solve it. Okay, the last ones we're going to do are 5 and 6. Page 198, 5 and 6. 5 is what's the domain. 6 is what is the range. It's going to ask us to write it in all of the forms. So I'm going to start with domain. Now it does say, what is a reasonable domain? Assuming the club makes a profit. So we're not going down here. The graph will extend down there, but we don't want to lose money. So we're just going to represent this because that's where I make money. So domain is X. What's the lowest X we can have? Didn't we find these points already? Negative 3, right? And this was 6. So your lowest is negative 3. Your highest is 6. Do we make a profit at negative $3? Then don't do that because that means include that number. I'll make a profit there. Do we make a profit if we sell it for a $6 increase? No. So don't include either. This is called inequalities because we have inequality notation. Now do interval notation. And then set notation. X such that X is an element in, well, let's think. Can we only have whole numbers? Can we only increase the price by $1, $2? I can go up by $1, $1.10. Can I have negatives? Can I decrease the price by 50 cents? I could. So we don't want just whole numbers. We don't want just natural numbers. We are going to do all real numbers because I can have decimals, negatives. Can I have any real number though? No, I have to be between that. So then you just tack that on. B is describing why we did that. We can skip that part. So we're going to go to 6, which is a reasonable range. Go ahead. Do it on your own, 3 different ways. Range is amount earned. So the lowest is 0. The highest was 506.25. From here up to here. Can I include 0? Will I be making money at $0? No. How about 506.25? Yeah, I would include that. So you're going to have parentheses 0. 506.25, then what? Brackets, because you're including it. Your set number, just like your range was, real numbers, and write your inequality. We've kind of been everywhere today. We wrote an equation. We graphed it. We found the vertex on the graph. We found the vertex using a new formula. We did domain. We did range, x-intercept, and y-intercept. The only thing that we didn't talk about, but we've done before, is it might ask you, when is your graph increasing or decreasing? Well, let's look at this graph. If I start here, is it going up or down? Up. So it's increasing from -3 to the vertex, which the vertex was at 1.5. When is your graph decreasing? This is when it's decreasing. So from 1.5 to 6. You wouldn't include the vertex because it's neither increasing nor decreasing at the vertex. Your homework only has one graph. You can put it in your book. Just know you won't be counting by ones. So make sure you tell me on your axis what you're counting by.